All right. Test 1 is tomorrow. Test 1, 10 a.m., lasts through noon. Test will be written primarily as a hour, 15-minute test, which means normal students should be able to get done in an hour. Do you have lab that afternoon? Yes. Okay. If you didn't have lab, I would say, then I don't want to see you for the rest of the day. Well, I still don't want to see you. But after that, 11 o'clock, 11:30, you guys should be done. This place will still be open for the test until noon. Then you'll definitely be over then. We will try to grade it that afternoon, if not the next morning. Test scores at the latest should be available by Wednesday afternoon, at the latest. From my perspective, 213 tests you on your knowledge of what you've learned in the last 6 days, which is difficult enough, but also it's to serve as a way to introduce you to taking a physics test. Most, if not all of you, have never taken a physics test before, or a bad physics test. So what I'm gonna do now is we'll do the same thing that we did on Friday. We'll go over a previous test 1. This test is from last summer, so you can get an idea of what's typically given on a summer test. It will eerily look like your test when you take a look at it. There will be a few modest changes to it. It won't be a word for word exactly like this test, but it'll be similar. I mean, my opinion is for the first test, there should be no great mysteries. There should be a few little, I want to see if you're paying attention type questions or aspects to problems, but it's not gonna be one of those like, I want to have some fun from the professor's perspective. As a reminder, pens, pencils, racers, colored markers, highlighters, bring a calculator, you're required to bring a green Scantron, those narrow ones with the 50 on each side. Do not bring books. If you do bring books or notes, put them in the bag, put them up front. Put your cell phone, turn it off, well, not right now, but take your cell phone tomorrow, turn it off, put it in your bag, leave it up front. That'll be very helpful. I love trying to hunt down phones that are receiving multiple phone calls. I think that's it. We'll come to more of it. Right now, the one thing that I really want to get across, I will catch someone in the test doing this. Feel free to mark up your test. You can put whatever notes on it after you get it. But the one thing that you do need to remember is I will not count the answers on your test for credit. They have to be either written on the Scantron for multiple choice, or they have to be on the scratch paper. I will bring in extra paper for you. Do not bring your own extra paper. Now let's do some of these. Number 1, which is not, and actually in this case, there are 2 expressions of force that are incorrect. B and D. Newton meter, the unit of force is a Newton, or kilogram meter per second per second. That is also not an answer. I'll have to go through that and make sure there are no multiples. 2 meters at 180 should be what in component notation? A, negative 2x hat. Tomorrow at the test, you should be able to instantly convert component to polar and polar to component. If I say negative y hat, negative 2y hat, you respond with what?
2 meters at 270.
Correct. Negative y hat is a is a 270 degree angle. One other thing about vector addition, it will be a straight up vector addition problem One will be instant. The other one will be probably a multiple of 30 or 45. They will not be cute or snarky vectors like you had on problems like 2 through 5 or something on the last problem set. A mass hangs from a string. Which quantity is 0? The normal force. Normal forces only occur when a force is sitting on something else. You convert square meters to square centimeters. You multiply by A, 10 to the 4th. You've got to square the centimeter conversion. 100 is 10 to the 2. 10 to the 2 squared is 10 to the 4th. Convert 2 nanometers into meters. It is D. A nanometer is smaller than a meter, so it's going to have the negative power. Nano, 1 times 10 to the negative 9. Real quick, what's 1 times 10 to the 9? Giga, correct. Normal force is always blank. Yes, question.
I had a question about 4. Can you like explain 4? Because I don't understand.
Okay. So if you had 1 meter or 1 square meter, you need to convert that into square centimeters. So it is 1 centimeter or 100. To get the units to cancel, you have to square it. So not only are you squaring the centimeters and the meters, you're squaring the 100. 100 squared is 10,000. 10,000 is 10 to the 4th. Normal force is always blank to the surface. What is blank? Perpendicular. If I had a slanted surface, which one is the normal vector?
We can't see that.
Oh, that one. Which one's the normal vector?
B.
B. What is the mathematical definition of normal? Or a normal vector? I mean, really, it's just what we covered. It's what? Sometimes, get a little bit more. What is the usual definition of the word normal? And we're not talking about antonym for abnormal. Perpendicular. The tips of my fingers are the vector heads. Is this parallel or anti-parallel? Parallel. If I drew it like this, it would be what? Anti-parallel. Good. Up is to down as resultant is to equilibrium. If I add a resultant and an equilibrium together, what do I get? 0. Correct. Chad Kelly throws the football to Coach Freeze. There is no wind resistance. The ball experiences acceleration that is only vertical. If I throw a ball up into the air, at the top of the curve, the ball's velocity is what? And the ball's acceleration is? Negative 10. Okay. In this particular case, the negative is important. If you said the magnitude is 10, then that would be fine. Convert 2 meters into centimeters. D, 10 to the negative 2. Your velocity is negative 3 centimeters and doesn't change. Your acceleration is 0. The sum of the forces on you, therefore, is 0 as well. What law did you use? Newton's second law. Newton's second law states what? Force equals mass times acceleration. So if A is equal to 0, F is equal to 0 as well. Yes. Chad Kelly throws the ball to Coach Freeze. Which of the following values is 0 when the ball is at its highest point? Vertical velocity. You are walking forwards and speeding up. Which is true? Yeah. Is this the one that we did? No, we didn't do this one. Okay. Symbol for coefficient of friction is B. The only other one that you should know at this moment is sigma for D. What does sigma represent? The sum. Excellent. Which is not a proper expression for the units of acceleration? Meters per second. Meters per second is what? Velocity. Which of the following is the largest? A. For an Atwoods machine, the masses accelerate at the same rate. Okay. The tensions in the string for an Atwoods machine, are they different, true or false? False. They are what? The same. The velocities of the objects in the Atwoods machine are the same. Okay. Which of the following in 18 is a fourth quadrant vector? E. Positive x and negative y. 19, negative x and negative y is a what quadrant vector? Third quadrant. Which of the quadrants listed in 19 are invalid? I'm sorry, I'm not even gone to 20 yet. I'm still on 19. Which of the quadrants in 19 is an invalid or incorrect quadrant label? The 0. There is no such thing. Object slides across the floor, which is not used? Static. We will be doing these figures. Let me get the figure. I'm looking for normal force in figure 2. The normal force for figure 2 is what number? 2. Did I do any of these? Okay. 1 is what vector, noting that the velocity is downhill?
Force of friction.
Force of friction. What's the relationship between normal force and force of friction?
Force of friction is
Mu sub k times normal force. Good. Which one is mg? 4. If that is theta, which one is theta in the triangle? C. What's the angle of B? 90. It's a right angle. So if C is theta, 5 is what? Mg sine theta. Yes. So if 5 is mg sine theta and 4 is mg, that makes 3 mg cosine theta. Yes. The odometer in a car measures what? Distance. You throw a ball into the air. Which of the following is a valid acceleration vector for the ball at its highest point? You said B?
D.
Oh, D. Thank you. All right. 24. You're walking forwards and neither speeding up nor slowing down. Which is the true? No acceleration vector. If you're walking forwards and your acceleration is forwards, are you speeding up or slowing down? You're speeding up. if your velocity vector is forwards and you're slowing down, in what direction is your acceleration vector? The opposite, backwards. Friction force is always blank to the surface. What is blank?
Parallel.
Parallel. Someone almost said perpendicular. What's perpendicular to the surface typically? Normal force. Name another force that's perpendicular to the surface. It could be gravity if the surface is flat. If it's a slope, what is perpendicular to the surface other than normal force?
mg cosine theta.
Mg cosine theta, or the y component of mg. Yes. So if you have stuff like that, just bam, 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 being able to go back and forth, the multiple choice should be done in like 10 minutes or maybe like 30 tops if you don't know what you're doing. But we got a whole 2 hours. I mean, we got tons of time. All right, next, problems. Now, a lot of this stuff, well, one of the things, big mistakes that I did back then, well, not a mistake, I just didn't realize it was unnecessary. We've only got 55, 56 students in the room. There's no reason to have multiple versions. This version was the freeze version. Let's do some stuff. Who wants to see a conversion problem? Okay. So 9 cubic meters per hour, and I'm going to convert it to cubic inches per second. 1 hour, 60 minutes. 1 minute, 60 seconds. Minute, hour, hour converted. Since the units are not cubed, I don't have to cube the numbers. These, the meters cubed, now I do have to convert and cube them. So 100 centimeters per meter cubed times 1 inch, 2.54 centimeters, again, cubed. Anything within a parentheses gets cubed as well. So this becomes 9 times 100 cubed times, divided by 60 times 60 times 2.54 cubed. And I get 152.6 cubic inches per second. You could probably get away with 153. Vector addition. A vector is 5 meters at 180. B vector is 6 meters at 300. Is A or B an instant conversion vector? A is. What does it instantly convert to? -5. Yes. -5. X hat or Y hat? X. Okay. So A vector is -5 X hat. The B vector is 6 meters at 300. What quadrant vector is it? Fourth. Fourth quadrant vectors have a positive or negative X? Positive. Their Y component is positive or negative? Negative. So we know what signs they should be. Let's figure out the magnitudes. So the first thing you want to do is you want to draw this vector out from an origin. You always draw the X and then the Y, so that you can always use the Y component as for the sine theta and the X component as the cosine theta. Now, this is your reference angle. the absolute angle is 300. If your absolute is 300, what's the reference? 60, because for fourth quadrant, it's 360 minus absolute. So this gives you 60 degrees. Now the quick thing, just for those, this is kind of an advanced question. Which one is 1/2, sine of 60 or cosine 60? Cosine of 60. Did you use your calculator? Okay, good. Sine of what is 1/2? 30. Sine of 30, cosine 60 are both the same, 1/2. Is cosine of 45 equal to the sine of 45?
Yes.
Yes, they are equal. So sine 30 is cosine of 60, which is 1/2, and sine of 45 equals cosine of 45. What I like to do in terms of, physics is not about the numbers, physics is about the understanding. So what I like to do is sneak in mathematical shortcuts that if you see sine of 30 or cosine 60, you just write 1/2 and then keep chugging. So what I'm trying to do is help a lot of people. So Bx, which is B cosine 60, or cosine, actually, let me write it out in theta form, is B cosine, dang it, 6 cosine 60, but the answer's still 3. It would be a shortcut for me if I could remember to write straight. B sine theta, or 6 sine 60. Never been I'm working towards, sine of 60 is square root of 3 over 2. 6 times sine 60. 5.20. And those are the parts. So the B vector is a positive x, 3, negative y, and now we've broken down our vectors. You add the components. Negative 2x hat minus 5.2 y hat. That's the C vector. Now in this particular case, I did ask for the equilibrium. I probably will since it's a 2-hour test. It's not that big of a deal anyway. For all you have to do to get an equilibrium is just flip the signs. And then you get that. So now we've converted, or we've done our addition in component notation. Let's get everything done in polar. C is a fourth quadrant vector. Once again, we draw our crosshairs and we draw our C vector. Negative x, negative y, that's the C. That is my reference angle. This is Cx, that is Cy. Cy is 5.2, Cx is 2. We're only dealing with magnitudes at this case. Yes?
For the resultant, why is it minus 5.2y if it's in the fourth quadrant?
If it's in the fourth quadrant? Because it's positive x and down. So,
But why is it like negative 2 and then minus, you know what I mean? Negative, negative, wouldn't that be?
no, C is a third quadrant. B is a second quadrant. Or I'm sorry, hold on. C is third, B is fourth.
Okay,
B is positive x and negative y.
okay.
And your question makes me doubt myself for a moment because that tripped me up. It is always, I never frown upon people trying to correct me. Theta r inverse tan of cy magnitude over cx tangent 5.2 over 2 . $69 degrees. 69.0, but that's good enough. That's the reference angle. For a third quadrant angle, we add 180. So the absolute is 180 plus 69. So this makes it 259. So yes, it's between 180 and 270 degrees. So my C vector is, oh, I haven't figured out the last bit. C is the square root of cx squared plus cy squared 2 squared plus 5.2 squared. .57 or 5.6 meters. So C is 5.6 meters at 259. What? What did I do? 240. Oh, that's right. Yeah, for the A. 249. Thank you. I heard the rumblings. It didn't manifest itself in a, you got it wrong. So 249. Now, one of the questions, or I should stop saying now. One of the questions that students ask is, well, Dr. Eschenberg, how many points do you get that on the, or how many points deducted off the test for something like that? For just a simple mathematical error like that, 2-3 points. It's not. In those final mathematical steps, if you trip up, you get like a 12 out of 15. If it's a really bad mathematical error, and I don't know what constitutes that, then you get a 10 out of 15. How it typically breaks down, you know what you're doing, you got it right, 15. You dropped a sign, we take a point. If you do a little bit of a math error, we take 3 to 4 points off. Now, if you get less than 10, there's a little bit more serious. 10 to 5 means there's some theoretical problems going on. And then 5 and below, we all know what that means. So, and if you didn't do it, it's a 0. For the equilibrant, since that is over 180, you subtract 180, 5.6 meters at 69 degrees. And so that's the answer for that.
For the resultant, if that's less than 180, then you'll add 180 to the resultant.
Say if the resultant was 130 for the resultant absolute, then the equilibrant absolute would be 130 plus 180, or 210 or 310.
Wait, the resultant would be 130 plus 180?
If the resultant's absolute, let's say, ignore this. If the resultant's absolute was 130, the equilibrant's would be 130 plus 180, or 310. And then that would be it. Problem 2 on the test. Given the motion below, what is V naught and T? When I see something like this, I go, yay, this is a good time. Because we're dealing with a flat surface, I will allow, and I need to remember to tell the graders this, for a flat surface, that's the only case where you can go, it's a flat surface, so max height time is 1/2 of total time. Done. It's only if I add the restriction of using the velocity equation, or I could even ask it in a test. Well, let's explore the situation. It's a flat surface, it's a two-dimensional motion problem. I don't even bother to read the problem, because the first thing I do is write x equals x naught plus v naught. I'll write cosine theta t, because that's what it always is. And y equals y naught plus v naught sine theta t plus 1/2 at squared. So the next thing is to get the sketch back in gear and define an origin. I'm going to pick the launch point as the origin. If the launch point is the origin, x naught and y naught are both 0. It starts on the ground. The horizontal component is right at the launch. So x naught and y naught are both 0. Now I've removed a sub x. It doesn't exist because gravity is only vertical. There's one more 0 in this equation. Which one is it? Y. It's a level surface. The final y is 0. So I'm going to rewrite this as negative 1/2 at squared equals v naught sine theta t. One of the t's cancels, and I'm left with negative at over 2 is equal to v naught sine theta. The only type of problem on a test where you have to find t and it's not quadratic are for situations where the surface is flat. If the surface is uneven, you've got to use the quadratic solution. And since I've said you will not be expected to use to determine the numbers for a quadratic, that only means that A, I have to give you the time, or if it's unlevel surface, or I have to give you a level surface. One of the two. Identify what you know. I know theta. I know I'm on the planet. I don't know V naught, and I don't know T, so that's a little bit of a problem. I still don't know V naught and T over here, but I do know X and theta. One of the problems, if not two of the problems that you'll get, will be 2 equation 2 unknown solutions. This is a 2 equation 2 unknown. The X position and the Y position are both have 2 unknowns, T and V naught. So how do we fix this? Well, solve for one of the variables in one of the equations first. Which one? I don't know. Just pick. I'll pick V naught over here. You get that. Now I'm going to plug this in over there. Now, one of the things that I'm going to do is simplify it by writing this. Tangent of theta is opposite over adjacent, or you could say sine of theta is or I'm sorry, tangent of theta is sine over cosine. So sine and cosine means the tangent would be in the denominator, and so it reduces the number of calculations you have to do in the problem. Now, what am I looking for to begin with? Just find t. So 2x tan theta over negative a is equal to t squared, or square root of 2x tan theta over negative a is equal to t. And that gives me the time. Two 63 tan 30 over negative 10 will give me 3.90 seconds. That's the time of flight. Now that time is a known quantity, we can solve for V naught. And this is such a classic Eschenberg thing to do. I don't like using the what's your question?
Why did you do square root of the time right there?
Because I need to solve for time. Time is expressed as time squared in this equation. So since I have to solve for time, I have to square root both sides. Hence the square root symbol.
Didn't we get rid of the time squared?
No.
The first step?
You know what? Yes, we did, but no, we still need it. I'll tell you why. Now I understand your question. Over here, yes, the squares, this square went away. So I'm left with negative AT over 2 equals V naught sine theta. And I solve for V naught, which is negative AT over 2 sine theta. But when I plug that into V naught over here, there's another t right there. And so that t ends up in a square. And so that's where a t comes from. Good. Real quick, what's 2 sine 30? 1. So whenever you see 2 sine 30, you know Dr. Eschenberg's being lazy. He wants you to understand the physics. He doesn't care about you knowing, or I know you know the math. There's no sense in getting that bogged down. So that goes down. 10 times 3.9 is 39. So the answer is 39 meters per second. I work hard, well, a lot of problems, I work kind of hard to make sure that you don't use the calculator. You can just look at it and just crank it out. If it makes you feel happy, you can crank it out. One of my goals, if I was staying here and teaching 213 and 214, you guys don't use calculators in the MCAT. I was going to eventually get rid of calculators in this course. Now, I understand that your calculator is like your personal little blanket of comfort, so I can let you guys keep it. But in a lot of problems, you don't need it. I just let everything cancel out. What is the max height? Well, the max height, since it's a level surface, and I do allow this on the test, that the time of max is the total time divided by 2. Now, one of the things that we could do to derive this is Vy, which is equal to 0, is V naught sine theta plus AT, or minus AT is V naught sine theta, or T is V naught sine theta over negative A. V naught is 39, sine 30, which is 1/2, A, which is negative 10. So 3.9 divided by 2 is effectively what it is, which is the same thing as we just said. So 1.95. What I did up here is I rewrote the velocity equation, and I said at the top of the curve that the velocity in the y direction is 0. So t is the time at which v sub y is 0. You cannot make this statement if it's an uneven surface. Max height, all you have to do is y equals y naught, which is 0, plus v naught sine theta t, plus 1/2 at squared. This makes it 39 times 1.95 plus 1/2, negative 10, 1.95 squared. So the answer is 57.0 meters. And so that's the maximum height of the object. So, conversion, vector addition, two-dimensional motion, third problem, always Atwood's machine. This particular Atwood's machine is a conventional Atwood's machine, which means I probably will put something tricky on it. Not tricky yet, but just see if you're paying attention. I will do this in the generic case initially, and then we'll plug in the numbers. One of the things that I will eliminate from your toolkit, and you will do it willingly, is your desire to plug and chug. If you can do everything generically, then doing something specifically is trivial. Oh, quick question which occasionally crops up in multiple choice. What are the units of mu sub k? There are none. There is one particular problem that or a multiple choice that I do ask is I give them a list of units and one of them is that newtons over meter kilogram per second squared. Can those be the units of coefficient? Yes, they cancel. Exactly. So what I do is I give them a list of units, everything which is a multiple of meters, kilograms, seconds, and newtons. And then you've got this one inside, and I say, pick the one that's the coefficient of friction. And everyone says, well, there are units in all 5 of them, but not that technically, because they cancel out, and then you get no units, which are the units of friction, coefficient of friction. So my axis of motion looks like this. I have never given, it would be interesting to figure out how. It would be similar to problem 9 on the problem set that's due this afternoon. I've never had A be negative. A for the test tomorrow will always be positive. It will always be to the right, or from your perspective, to the right and down. That means what is the minimum value of A that you could have on this test problem? 0. If it's less than 0, there's a problem. What's the maximum? 10. So the number that you get tomorrow in the test must be between 0 and 10. And most likely, I will try to make that, hopefully I'll remember, that number will be an integer or an easy fraction. An easy fraction, I mean multiple of 1/3, 1/2, stuff like that, or 1/5. Something that simple. When doing a problem like this, you sum the forces on each of the objects. I'll do the second one first. That's tension. Tension is up. Hanging gravity, or the mass of the force down, is m2g. It is accelerating in that axis. So the sum of the forces, which is m2a, is equal to minus tension plus m2g, which means that tension is m2g minus m2a. And that's the calculation of tension for mass 2. I'm probably not going to ask you for the tension of it, so you can just keep going with just solving for tension. Block 1, you have normal force, you have m1g down, you have the tension to the right, you have the friction force to the left, and that's because the velocity is to the right. Hold on, one last thing I need to remind myself. Okay. For something like this, since forces are acting in both directions, you have to follow the standard procedure. Some of the forces vertically are equal to 0. It doesn't penetrate. So it's Fn minus m1g, or Fn is equal to m1g. It is not always that. One of the things that I was trying to teach, I did it on the fall test. I won't do it on the summer. The summer test I have to be very easy. I add an external force. I added an external force to the atwoods machine. If you see an atwoods machine problem where there's an additional force coming down at an angle on this guy, that was from last fall. It's not, that part won't be on the test. Something like this will. Coefficient of friction is mu sub k, because it is mu sub k Fn. Now I've got to sum the forces in the plane of motion. Left is negative, right is positive, therefore minus F plus tension is equal to m1a, which is equal to the sum of the forces on block 1. So that means tension is equal to m1a plus friction force, which is equal to m1a plus mu sub k m1g. Set them equal to each other because the tensions are the same. Oops. That should be a positive. There we go. Now solve for A. m1a plus m2a equals m2g minus mu sub k m1g. A, m1 plus m2 g m2 minus mu sub k m1. And then A is g m2 minus mu sub k m1 over m1 plus m2. And that's the acceleration. So we should get a number that's greater than 0 but less than 10. M2 20 minus 0.17. I need to start picking out more responsible numbers. 7 plus 20. Because that's 19.3 in the 10 times 19.3 divided by 27. And I get 7.15 meters per second squared. Now this is the generic solution that you need to do in the test tomorrow. So if you know how to do this procedure, you've got a lot of this covered for the test. Now, most likely, I gotta do some things to make this a little bit more entertaining, is a lot of you, and this may be the big lesson for tomorrow, it may be me introducing the idea that these plug and chugging students need to mend their ways and see the light. So what could I do to make this a little bit more interesting? I could add a ratio. I could say that M2 is 5 times M1. And then everybody would lose their minds. Because I didn't give you the mass. You've got to have your numbers. I must have my numbers. No, you will not get your numbers. Because sometimes I don't give you numbers because you don't need them. If the problem had said this is the mass ratio and I did not give you M1 and M2, all you would do with that is plug in a substitution for M2. And I will do that before finishing the problem. G M2 5M1 minus mu sub k M1 over M1 plus 5M1. Factor out an M1. G M1 5 minus mu sub k over 6M1. And then that's the answer. And then you plug in 10 for G and whatever mu sub k is. The other thing that I could do for something like this is I could give you everything or have you figure out what A is and then solve for any of these other variables like mu sub k. And what I'm going to do is I'm going to finish this problem and then I'm going to rewrite it so that you're going to have to find mu sub k as your final answer. If I know that A is 7.15 and I know this length is 20 meters, I'm going to set the origin there and the x coordinate is 20. The v naught is 0. It's a simple one-dimensional motion problem. X equals x naught plus v naught x, or v naught t, which is 0, that's 0, plus 1/2 at squared. So to solve for the time, 2x over a is equal to t squared. Square root of 2x over a is equal to t. So square root of 2 times 20 over 7.15 is equal to 2.37. So those are the answers, and this is just some extraneous stuff. You should be able to take these equations and manipulate them to whatever numbers or factors or quantities that you need. Let's say, for instance, that I change this. Hold on, what do I need? Okay. I'm going to change the problem. In this particular problem, M2 is equal to 4M1. Mu sub k is an unknown. It takes, I gotta choose some numbers that work out well. It's a distance of 20 meters. The time that it takes for it to fall where the initial velocity is 0, that time is 4 seconds. So this is the problem. It takes 4 seconds for this object to drop 20 meters from a rest. You're only given that M2 is 4 times that of M1. Give me mu sub k. Now, in this type of problem, you've already done all this derivation. You've gotten to this equation, and you've set it up so that you can stop at that equation. The derivations to there and to there are the same. You still sum your forces in the horizontal for M1. You still sum your forces for the vertical on M2. But this is where things get different. If I know what L and T are, I know that 2x over t squared is equal to a. I know what the acceleration is given those two values. And so fine, we'll do the math. Oh, actually, the math, hold on. This lets me know that the math, I need to do something different with this. 240. No, the math works well, I think. Okay. A is 2.5 meters per second squared. 2 times 20 is 40. 40 divided by 16 is 2.5. So I have the acceleration value of this equation. Now, I've done my derivation that I've shown before for this page and for this page, and I got to here, and I said, I need to solve for mu sub k. I know everything else except for mu sub k. So then I plug in M1a plus M2a is equal to M2g minus mu sub k M1g. If you guys were plug and chuggers from the start, you wouldn't be able to do this. You wouldn't be able to just pull the equation out in general form and then specialize it. Mu sub k M1g is M2g minus M2a minus M1a. So mu sub k is equal to, let's do our substitution. 4m1 lap. 4m1g minus m2, dang it, 4m1a minus m1a all over mu m1g comes down. Factor out the m1 out of the numerator. Mu sub k m1 4g minus 4a minus a over m1g. So the m1's cancel again. And I'm left with 4g minus 5a over g. Now, one of the things that you can do in looking at this, go, I don't believe it. Is this a good equation? Do the units tell me? And think about this. Remember that question how I said is newtons over kilograms meters per second squared the units of coefficient of friction? That was asked because problems like this crop up. What are the units of gravity?
Meters per second squared.
What are the units of acceleration?
Meters per second squared.
So when you add meters per second squared to meters per second squared, what do you end up with?
The same.
The same thing. And then you divide it by the units of g. What do you have now?
Nothing.
Nothing. So the units do check. And so if you saw something like this and you doubted it, and you did the units and it worked out, you feel good about yourself. You feel confident. If the units didn't work out, then you immediately know that there's a problem, Houston. And then you just go back and fix it. So this becomes 4 times 10 minus 5 times 2.5 divided by 10. So 40 minus 12.5, 28.5 I think, divided by 10, 28.5, 2.85 I think. Now one of the things about coefficients of friction, there is no limitation. Coefficients of friction cannot, well, there is one limit. They can't be negative. They can be greater than 0. So 2.75 is a fairly hefty coefficient of friction. Ice, fairly close to 1. This thing is more like this surface or rubber or something. I mean, it's really sticky. But it illustrates a couple of points. Unit checks, being able to solve for any of the variables. I would say that this is the core equation. Be able to solve for any of the variables. One lesson that I talk about is I love it when students say, I've never taught that. Well, if I've taught you what A plus B and you calculate C from it, I kind of understand that you are to be able, given A and C, find B. So if you know the equation is A plus B equals C, and I give you A and C, you have no right to say I've never taught that. This is just basic problem solving, which is one of the things that we're doing this summer. Be able to take that equation and solve for any of the variables, M1, M2, G, and A. Be able to substitute in that equation into this, and then be able to solve for T, X, or A given the conditions. Be prepared to do a substitution. Most likely, those masses on the Atwoods machine are going to have a ratio of masses. Or I could ask for the ratio of masses. I could give you because see, I have to give you a correctly constructed problem. If I say, well, if M2 equals blank M1, and I ask for you to solve for the blank, that means I have to give you t and x, or two of the three of t, x, and a. I have to give you, then give you mu sub k, and and you're going to have to figure out a from it. But I have to give you all the variables except for the one that I'm asking for, or not give you variables that you don't need anyway. So it is going, I promise you, it is going to be a problem that works out. It's not going to be, long gone are the days where I write problems where the answer is, oh crud, I forgot something. And 213 test 1 is the easiest test to write for. I'll make it work. One last thing before I open the floor to questions. Ooh, I have this stuff all written down. Okay. One last moment of rapid fire questions. If E is acceleration, which one is velocity? D has a negative slope, E has a negative value. If E is acceleration, which one is position? G, yes. Because velocity's value decreases and eventually goes to 0. The slope of that line eventually goes to 0 as well. If A is position, which one is acceleration? C. Does A show acceleration? No, because the slope is not changing. So if A is the position, which one is velocity? B. Why is it not E? Because then the slope would have to be negative because it's a negative velocity. If F is position, which one is acceleration? E, correct. Because it's slowing down going up and it's speeding down as it's on the other side, which means there's a negative acceleration working on. Is D a valid plot? Is D a valid velocity plot for F?
Yes.
Is it valid for the entire time for F? No. If it was to be a valid plot for the whole flight of F, it would have to look like that. Because this has a positive slope. Over here, it has a negative slope or negative value on the velocity line. If H is position, which one is velocity? A, correct, because is the slope increasing or decreasing for H? It's increasing, so you're going to have a positive velocity, and not only a positive velocity, but a positive velocity that increases. Very good. So you're going to get stuff like that. You're going to get labeled that inclined plane force diagram. And then you're going to get some problems that we know. The test 1, I know you're anxious. You've got anxiety. Set that aside. Test 1 is the most boring of all the tests. It's basically, I need to get you in a room and have you be able to show me that you can go through the basic motions. If you can't get through the test tomorrow, talk to me and we need to decide what we're going to do, because we've got an interesting problem. Normally I would say, horrible. If you get like a 20 on the test tomorrow, then talk to me. We can fix a 50. And think about this. If you do halfway decent on the multiple choice and then trip all over yourself and get partial credit on the problems, you've got a 60, at least. So it's not a test that you can outright bomb. There's always going to be something that you can get out of it. If you get a 20, as in you blank out and don't do anything, then we need to talk about it, because I'm not going to be here in the fall. I may tutor in the fall, but I'm not going to teach it. So then we need to prep. Those are the tests. When you review, look at this lecture, which will be online 1-ish. Look at the problem, look at the test review that we did on Friday. That's already sitting on YouTube. I would look at those two problem sets, or those two lectures, and if you can go backwards and forwards, you're done. You can do anything. All right, let's talk about anything that you guys want to talk about. And we're going to try to stick here for till 11:50, so I can hear the bags packed. That just means we'll go to 12:30 on the lecture. What do you want to talk about? Or do we all know everything? Is there a lab this afternoon? No? Okay.
Is it tutoring?
Yes. At 1 o'clock through 6, there will be tutoring. The TAs, definitely for 223, and I think maybe a 221 TA will be in there. But from 1 to 6 this afternoon, it will be staffed. My office hours are from 2 to 4. And then that's it. So what do you guys want to talk about? Or do we know everything? Cricket, cricket, cricket. So conversions is easy. Vector addition. You know the multiple choice for vector addition. Just one thing to remind you. Don't put in negatives. If you put a negative sign into your calculator, I'm going to know it and I'm going to freak out. Atwoods machine and 2D motion. Yes?
Will you give us a negative number on the vector addition?
I won't give you initially a negative theta. I won't give you, I apply the anti-Stark rule to myself as well as to you. So you're not going to get negative 2 meters at negative 90 degrees. Add that up. So, no. It'll all be positive magnitude and angle. So it's going to be a straight up fight when it comes to that vector addition. Yes?
I have a question that was on with the past test. It was number 17, and it said static friction force is, AB's.
Which one? Now they're pretty much typos.
Yeah, it's 17. I just didn't know if it's US.
Oh, let's do that. So static friction force is what? Now, 17, the answer is not C. C is the coefficient of static friction. Which one of these is static friction itself?
Force times use of S.
Yes, so it is E. Yes. D is what? Kinetic friction. And B is nonsensical. So it is mu sub S is, if I had said which one is the coefficient of static friction, your answer would be correct. 1 and 2, yes.
Did you do number 4 on problem set 2? It's,
Number 4, let me see if we need to do this at all. Okay. Answering her question, you're not going to get negative values for the magnitude or for the angle. So, in this problem, if you haven't done it for homework already, look at the tutorial 2 from the spring where I add vectors, and I do this problem. So you will need to know more something like that plus this, like conventional instant conversion vector plus something non-conventional. Yes, your question. Number 11 on multiple choice. Oh, you are walking forwards and either speeding up or pointing down or slowing down, which is true. You have no A. If I'm walking in this direction and I'm speeding up, acceleration and velocity vector are in the same direction. If I'm walking in this direction and slowing down, they're in opposite directions. So that's the gist. Yes?
So for this test, the atwoods problem, you're just gonna give us a ratio or solve for use of K.
I could, yeah, or all sorts of things. I could ask for acceleration. I could ask for time, probably not tension. I could ask for specific mass. Like, I'd have to rewrite the problem so that it's a specific mass. But the thing is, with an Atwood's machine problem, I've shown you how to derive that equation and that one. So if you have those two equations, all that matters are the conditions that I give you. So I can go in all sorts of weird directions. I haven't decided yet.
So how would you derive that one from CD?
For this?
No, the one at the bottom. How would you derive that?
Oh, this? Well, that was derived by all of this. Hold on. So those two tensions are equal to each other. So I took those and plugged them in there. The same thing. And then from that, you should be able to get anything I ask for. That's why a lot of people get, the plug and chuggers get so freaked out if I've given them different numbers that they've never seen before. What I'm trying to teach you to do is Atwood's machine is a very easy problem. Solve it generically or generally, and then you can solve for anything. It doesn't matter what I ask for. Yes?
So on the test, you're gonna want us to show like how we.
I would, yes, right. The graders are just like me in the sense that they do not like to see poof and a miracle occurs and then final equation. For the 2D motion equation, don't use the range equation. Start from my two favorite equations. You're allowed to start from there. The range equation is a very specific equation, and it can be easily misused. And so I would just recommend start from scratch. More. Like this. So you know all of physics now? Which one? What's your biggest problem? Atlas? Okay. Just 3D practice. What's your biggest problem?
2D motion gets kind of confusing.
2D motion gets kind of confused. How so?
I don't know, it just depends on which question, I guess. They all seem sort of different to each other.
Okay. Oh, okay. Good. Now, what you had said, it just depends on what they're asking for, is in the same vein as the Atwood's machine. If you know how to do a 2D motion problem generally, you can do any two-dimensional problem. Now, what I would typically throw at you is, I'm going to split that level. Also, as a, the psychology of Dr. Eschenberg, for a lot of tutors tell their students, pay attention to what he does during these review sessions. Also, I think the Test 1 review session from spring is online. If not, I'll pull spring's or last fall's Test 1 review and throw it on YouTube. When you look at these review sessions, you're basically looking at Dr. Eschenberg working through sample problems and seeing what works and doesn't work. If I encounter a problem that just trips me up and looks like a big disaster in front of the whole class, Dr. Eschenberg gets kind of afraid of doing problems like that online or on the test. So in certain circumstances, when he sits there and goes, oh, there's a very nice problem. I'm not saying that this problem will be on the test. I'm just saying that I'm playing with it and I just want to see what goes on. The thing goes up, the thing comes down. The origin is always on the lower left-hand side. Now, granted, to a lot of different professors, they put it anywhere they want. I try to be consistent. The other thing that I'm promising you that it won't do is it's not going to slam up against the side of this thing. So the answer won't be, it's going to land here. I'm always going to pop it on top of the roof. It has initial coordinates. X naught is equal to 0 and Y naught is equal to 0. And to those of you listening not in my class, they just started. Be gentle with these kids. So the final X, I'm going to make it unknown, but the Y, the final Y, is the height of the cliff. So whatever that is, I'll just say Y for the moment. I have to give you I'm going to be obscene about this. Y, in terms of the number selection. Y is 100 meters. This particular length is 150 meters. Theta is equal to an unknown. Do I need, I'm going to have to not give you V, or V naught is, this is the number that I'm going to pump it up, 300 meters per second. The time is 40 seconds. What I want to know is how far away from the edge of the cliff did it land? So I want to know that length. Which means we're going to have to take X and deduct 150 from it. And give me the angle. In all two-dimensional motion problems, you set the origin first, lower left corner. The next thing you do, you write out your basic X and Y position equations. X equals X naught plus V naught cosine theta t. You can just write it like this. And Vy, I'm sorry, not Vy. Y equals Y naught plus V naught sine theta t plus 1/2 at squared. In all two-dimensional motion problems, always start with the origin selection first. So let me write this stuff down. The origin selection and then the positive, negative directions. In a two-dimensional motion, it's going to be conventional. It's going to be just the standard up positive, down negative, left negative, right positive. I always have, because this is 213, the objects always go to the right. Up is always positive, down is always negative, the right's always positive. The next thing, write out x and y position equation. Since when has this never happened? This has never happened. It's always come out origin, x, y equations, always written out, regardless of what the problem looks like. 4, or I'm not 4, see, I can't even count. Plug in zeros. It starts at the origin, which means initially its coordinates are 0. And those are the only things that we could plug in. 4. The known and unknown identification. If you know it, green line beneath. If you don't know it, red line above. I write it this way because occasionally we get colorblind individuals. So typically I just use colors because I can see them, but for the colorblind I write below as a known and above as an unknown. So let's ID what we know and don't know over here. I know I'm on the planet Earth, and I know my time. So those are all known quantities. I know what my final y is. It lands on the cliff. And if you look for problems similar to this, there's the one problem that I first started writing about, and I used it for the first couple of years that I taught, the Tiger Woods bunker problem. Tiger Woods is in a bunker. The green is, well, in this case it's 100. This is a bizarre bunker. But the green is so many meters above him. He's so far away from the wall of the bunker, he hits the shot with these conditions. Where does it land? How long does it take? Blah, blah, blah. This is the same thing, except that it's just bigger numbers. I know my V naught. But I don't know theta, and I don't know x. These problems that you're doing in 213 break down after part 4. When you look at 5, ID 1 equation, 1 unknown, or 2 equation, 2 unknowns. One of the equations will have just 1 unknown. The other equation may have 2 unknowns. If you've got one equation with 1 unknown, you attack that sucker. If both equations have 2 unknowns, then you use the 2 equation, 2 unknown solution and then grind it out that way. In this particular problem, the way that I have it set up, one of the equations only has 1 unknown, the angle theta for y. So I'm going to figure that one out. Y minus 1/2 AT squared equals V naught sine theta t. I have t, I'm just looking for theta. Y minus 1/2 AT squared over V naught t sine theta. So theta is inverse sine of y minus 1/2 AT squared over V naught t. Now let's double check something. The units of y are in meters. What are the units of AT squared? A is in meters per second squared. Yeah, Time is in seconds squared, so those cancel. V naught T, meters per second times seconds. Seconds cancels. So meters minus meters divided by meters is nothing. Can you take sine of something that does have units? No. You can't take the sine of 3 meters, but you can take the sine of a ratio, a number which has no units. So this is a valuable or a doable equation. So the theta y100 minus 1/2 negative 10 40 squared over 300. Now the numbers may be weird. This is most likely going to give me a theta that's like 88 degrees or something, which is kind of a dumb angle. But what I'm going to do this afternoon is I'm going to write the spreadsheet equation, and then I'm just going to play with the numbers until I get something decent. Oh, it's kind of decent. 42.5 degrees. So it's not that bad. Which means this thing's going to go far. Theta is now a known quantity. So x is equal to V naught 300 cosine of 42.5 time of 40. So we're looking at most 1,200 meters. Or no, 12,000. Ooh. $88.47 meters. And so that's it. This procedure here, wow. This procedure here, if you follow it, it'll never let you down. You just have to be meticulous about it. Don't worry. A lot of you get tripped up with, but what if? No. Keep faithful to the path. Stay on the path, everything will be fine. Walk off the path, velociraptors eat your face. It's that simple. You come back with no face, I then know that you did something wrong.
You do subtract 150 from that, right?
Oh, yes. The last bit. See, they even came after my face. This is the x-coordinate, which means this distance from over there to way over there is 88.47. So then this distance is whatever that is minus 150, 86.97. And that's the final answer. The numbers, I'm going to try to make the numbers work out. The reason why the numbers look weird, or that one's so big, is I'm doing this on the fly. If I've got a spreadsheet, I'll make the numbers look a lot better. But in this case, it doesn't, so let's just deal with it. Okay, we got about 10-15 minutes. And so that's two-dimensional motion. It really is. Test 1 for summer 213. A, you've only been taking physics for a month. B, you've never had physics before. C, it's your first test. So D, I gotta make it, it's gonna be a nice, fair, quiet test. Let's just get through it. Don't panic. I've never had a student panic in my office before, so I don't know how to handle it. And so that's just it. So any other questions? Yes?
You wanted to find like the maximum height?
Oh, let's do the maximum height for that. So the time is 40 seconds. Can I just use 20 seconds? No. Why? It's an uneven surface. It's not level. So what I have to do is I have to use Vy equals, well, what's the velocity at the highest point? 0. And I write out the rest of the equation. Oop. No, not you. Not you. God, I'm horrible right now. It's Monday. So Vy is 0. It's equal to V0 sine theta plus AT. A is -10. So minus AT is, oh, and what I'm going to really look for, I want to know the X and Y coordinates when Vy is equal to 0. We got to have a question for this. So what you've asked for is, oh, and the other thing is, I want T as well. Give me the coordinates and the position at maximum height. Coordinates, which is position, and time at max height. That's what I'm looking for. So V0 sine theta. T is V0 sine theta over minus A. So this is 300 sine of, oh goodness, 42.5 over a minus 10. That becomes 30 sine 42.5, 20.3. Now granted, it's close to half, but it isn't half. So if we're grading this and you just cut the time in half, we're going to come after you, even though the time is fairly close. So I've got the time. What about the coordinates? X equals x0 0 plus V0 cosine theta t. There's no horizontal acceleration. So this becomes 300 cosine 42.5, 20.3. $44.90. Which definitely is not, well, it's fairly close to this, but it's off by a little bit. The y coordinate, y equals y0, which is 0, plus v0 sine theta t plus 1/2 at squared. Oh goodness, 300. $61.68 meters. It's its y coordinate above cliff, if I'm asking for that, is y minus the length, the height of the cliff, which is 100. So it would be 60, 68 above the cliff, or a max height of 61, 68 above the floor. But when it comes to max height, the thing that you attack it with is that, not that one, use this one. And then to find the position, you use the position equations. And so that's a good max height problem. I'd have to simplify it a little bit. Probably, if I was going to ask this as a test question, I would use this, and then I would simply ask, what's the time at max height? And then I would say that that's a heavy duty problem, but not total crazy. If I asked for its coordinates, now we're talking about a problem that's technically, in my opinion, 2 problems long. Maybe not for an honors class, but this is not an honors 213. It's just regular for us regular folk. But that's a very good problem. Having to use this, understand this, do some algebraic manipulation, and then everything works. Goes without saying, you can come into my office and ask me general questions, but don't come in and annoy me because I'm writing the test. And annoyed professors, they get cranky, and then they start writing fun problems. I think that's it. See you tomorrow at the test. Good luck.